All right, it's 7 a.m. Um, Good morning. Thank you everyone for being here. Um, I'm Mike. I work with Jinsco. I'm the FSR here out of Portland, Oregon. Um, we're gonna get started. We're gonna go over some heat pump air codes today. Get a lot of questions, people not understanding maybe exactly what's going on with the air codes, what they might be referring to, because there's not a lot of air codes, but they refer to kind of generic stuff. So we're gonna go over what all that means today. All right. There's can be just one or two parts to your to what we're going to be looking at. So you have a defrost board, which watch this is a very poor laser pointer. There we go. On here on the left, kind of what you're looking like when you're going to see it in the most of our units. And you can also have an EEV control board. And they're going to look a little bit different. If you have an EEV control board, you're also still going to have a defrost control. It won't look exactly the same as this one, but it's going to look similar. You have a lot of the same stuff on there. Still going to have lights and air codes and stuff like that. But you're going to be starting off by just kind of identifying what board is giving us an air code. So if you look here on the defrost board, you have some lights down here in the bottom right. And on the EEV board, we have our lights right here on the right. So depending on which board is giving you the air codes, it's going to depend on where you're looking for the air codes and what the problem might be. We'll start here with the basic defrost board that is in most, if not all, of our current single stage heat pumps. So that includes our 14 SEER, our 15 SEER, our 16 SEERs. They're going to have two LED lights on them. They're going to have a red one and a green one, like I said down here. The green LED light is just a status light. It's going to give us one flash per second when it's idle and two flashes per second when it's actually heating or cooling. So the green light, we want it on. It's flashing, just going to tell us if there's a call for cooling or heating or not. That's all it's doing. It's not going to give us any other errors other than it's on and has power, really. The red LED light right above it here, that's what's going to give us our faults. So I have had some people call and they ask, oh, I got the green light flashing twice. I'm like, well, that's great. That just means we got an active call. It's not a problem. So green light just tells us if it's running or if it's not. The red light's going to give us any problems that there's going on. Before we get into those actual lights, let's look at what other options are on this board. So there's in the service facts, you have this whole list of settings, how that board is pre-programmed to do certain things. There's certain things in here that are more important than others. And let's go over those important things to understand so you know what it's looking for when it's doing what it's doing. The first big deal here is the defrost enable temperature. So what this means is, unless it's below 52 degrees outside, it will never try to defrost. So if we're 55 degrees out and that coil's frozen, it doesn't care. It will not even look, try, or think about defrosting unless it's below 52 degrees. So that's measured by the ambient temperature sensor. So if you have a frozen coil and it's 55 degrees outside, it's actually doing what it's supposed to do. It's not supposed to defrost at that point, even though it's frozen solid. That's we have to thaw it manually by putting it into cooling mode or whatever. You're going to have to find out why it's freezing up without being cold outside. It should not freeze when it's above 52. The second thing that's important here is a defrost permit. So the coil itself, the coil temperature sensor, has to be below freezing. If it doesn't think the coil's frozen, it'll never try to defrost itself. So it's got to be below 52 degrees outside, and the coil itself has to be below 32. So you have two temperature sensors. One is the outdoor ambient temp sensor. The other is the coil temperature sensor. We got to make sure those sensors are reading the right temperature before we even try and go into a defrost. We do have a minimum defrost time of 1 minute, a maximum of 15. The target is 4 minutes, which means it's going to change its algorithm and change what it's doing, but it's trying to get the coil defrosted in 4 minutes, give or take. The next thing down here, this is one of those things where we're going to talk about actually adjusting, is this defrost termination temperature. So there is a jumper, it says JPR2, jumper 2. what that jumper does is it changes the temperature at which it comes out of a defrost from 47 degrees to 70. So normally when it goes into a defrost, the coil's below 32, we'll say 30 degrees. It's frozen. It's below 52 degrees outside, we'll say it's 45. It goes into a defrost, it switches over into cooling, and the coil starts to warm up. And as soon as that coil hits 47 degrees, and it's been over 1 minute, it will terminate a defrost. It will switch back into heating because it thinks that 47 degrees is enough to thaw the coil. In the Pacific Northwest, that's not always the case. You'll find a lot of times where it'll come out of a defrost and there's still ice on the coil in places. The way to eliminate that problem is you cut this JPR jumper number 2, and we'll look at it right here on the board. It's right here on the bottom left where it's marked JPR2 or term, TERM. So you need to cut that jumper. It's just a little wire loop on the board, and you'll just take a pair of wire dikes and just cut that jumper. Once you've separated it, and now we'll continue to defrost until that coil temperature has reached 70 degrees, which is a lot warmer, and it should be more than enough to make sure all the ice is melted off the coil. That's the big one right there that we talk about the most with technicians in the field, just making sure they cut that jumper and understanding what it does. Once you understand what it does, it makes perfect sense and you can identify it. And that's been the same on our boards for a long time. So if you see JPR2 or jumper 2 or term, it's hard to see it down here, but it says JPR2, it says term. That's what that does. It's going to make sure that coil gets really hot before it comes out of a defrost to make sure we melt all the ice. Just make sure that it's clear of ice. That way you can heat better coming out of a defrost. The next part on there is something that really I don't think that many people have to worry about is the soft switch over. This is the time in which it's switching from heat to cool and cool to heat in a defrost. If you leave it alone, it's supposed to shut off the compressor for 12 seconds. If you cut jumper number 1, it should not turn off the compressor. It'll just switch straight from heat to cool and cool to heat. What it's supposed to do when you don't cut it is have a 12-second delay in between. It should shut off the compressor for 12 seconds, switch over the valve, then turn it back on. It's just about making it's actually quieter the way it comes out the box. If you cut that jumper number 1, which is right back here, right next to jumper number 2, soft switch over. If you cut it, there's a 0-second delay. In other words, the compressor never shuts off, and it could be a little bit noisier when it switches from heat to cool. So we don't recommend cutting it, but it shouldn't actually hurt the system. The last couple things down here, just understanding how the system works. If it does get cold, and we do have some environments, and for some people out there, Montana, Alaska, where this could come into effect. If it gets below -12 degrees, we're going to shut off this heat pump. It will lock itself out. It will not run. If that ambient temp sensor reads below 12 degrees Fahrenheit, -12 degrees Fahrenheit, sorry, it will shut itself off. So if you're in an environment where it can get that cold, understand that if that ambient temp sensor reads below -12, it will not run. That's normal. That's what it's supposed to do. And if it does drop below -12, say it goes to -13 and warms back up, say it only gets up to -5 or -8, it will still be in a lockout until it gets above -3. So we have to get, it's not like a 1 degree, there's like a 9-degree deadband there where it has to, once it crosses -12, it will not come out of that lockout until we get above -3. That's the big things to understand. Some people in Seattle market or Portland or stuff like that, you may never run into this, and that's fine. But for those of you who do, that's what's going on. Jumping into the first fault codes. On our boards, we have a few fault codes. The first little bunch here, you'll notice we have a flash code, right? So you're gonna have a 1 flash, 2 flash, 3 flash, 4 flash, so on and so forth. The first two are about our temperature sensors. So if you're getting a 1 flash, it's referring to the ambient temperature sensor. If you're getting a 2 flash, it's referring to the coil temp sensor. If you're getting either a 1 or a 2 flash, what I would recommend you do is you take a look at that sensor, ohm it, and make sure that it is not broken or bad or shorted out, because that's usually what's going to happen there. Usually if you're getting a 1 flash or a 2 flash, you have a coil that has been chewed on by a critter, just for whatever reason gone bad out of its own accord. It's no longer functioning like it should. The defrost board cannot read it. It either sees it as open, so it's OL, or it's shorted to 0 ohm resistance, and neither of those are going to be a functional readable number. So 1 flash and 2 flash, really simple. They have to do with the 2 sensors. The 1 flash is the ambient, the 2 flash is the coil. 3 flash, this is going to happen on an active low pressure cutout. So this gets a little bit kind of weird because what they usually get is a 5 flash, but we'll get to that next page. 3 flash means you have an actively open low pressure switch. So if it is flashing 3 flashes, that means at that very moment, low pressure switch is open. So I would recommend you put your gauges on it, gauge up, and see what our pressure is. If the pressure is at 200 psi and you're still getting a 3 flash, that's really indicative that we have a failed low pressure switch because it cannot get voltage through it right now. It's just an open closed switch, and at this point, it's open. So that could just be a failed low pressure switch. Also could be a failed defrost board that is not sending voltage out. So I'd want you to put your gauges on it, check the refrigerant pressures, unplug that pressure switch, ohm it out, see if it's got continuity through it. And if it does, let's check our voltage going to it from the board. The 4 flash is a hard lockout. This is one of our most common calls we get on our heat pumps in the wintertime or the summertime. But mainly in the wintertime, we get a lot of these 4 flash. 4 flash means you've had that 3 flash happen 9 times. So it's happened 9 times, which means this has been an ongoing low pressure problem for a while. And it finally just said, let's go into a lockout and get someone out here to fix it. It's kind of their way of getting the homeowner to notice the heat pump's not working. So if you do have a 4 flash, that is going to be solely due to 9 times of a low pressure cutout. And that's it. It's not something else. It is a low pressure problem. Low pressure problems can be caused by airflow. They can be caused by refrigerant. They can be caused by people running it at improper conditions. So if you have a homeowner who's trying to cool the house to 60 degrees when it's 40 degrees outside, you might get a low pressure trip. That can happen. The 5 flash, this one we get a little bit of. If you're getting a 5 flash, you're in a soft lockout. That's typically caused by our low pressure cutout tripping and then resetting. So if we go back to this, you get a 3 flash. As soon as that pressure comes back up, it seals the low pressure cutout, and then it goes to a 5 flash, and you're in a soft lockout. Soft lockouts can be 5 minutes to 18 hours, depending on how many times it's been in a soft lockout, how many times this has happened. So if it's your first time it's happening, it'll be a 5-minute soft lockout. If it's the 8th time it's happened, you're in an 18-hour soft lockout. So there could be a lot going on there. So if you see a 5 flash, that means you had a low pressure cutout and it reset. That means there's enough refrigerant in there to close that low pressure cutout back down. 6 flash, not so common. We don't get this as much, but it's saying that it's caused by it's a short cycling of the defrost. In other words, it went into a defrost, it defrosted, came out, it went right back into a defrost again. If it keeps on happening over and over again, this is going to cause the 6 flash to happen. That's going to be caused by a couple of things. One could be a faulty sensor. It could be a sensor in the wrong location. Maybe someone replaced it and put it on the wrong tube, and so it's getting cold too fast. And so it keeps on going into repetitive defrost. So that's going to be a charge issue or a sensor issue, most likely. So if you're getting a 6 flash, let's check our sensors, our coil temp sensor, our ambient temp sensor, and let's check our, where they're located. Are they on the right places? Also, you want to check your charge. Make sure if we're under charge, it's going to be frosting up much faster than it should. The last one here is a very rare one. Comes down to that we're too cold outside, below -12, so a 9 flash. If you're in an environment where you're not below -12 and you're getting a 9 flash, that's pretty indicative of a ambient temp sensor that is reading incorrectly. Pretty simple. It thinks it's -12 or below, even though it might not be. So, but if it is below -12, you're going to get a 9 flash. It's going to let you know that it's in that low temperature lockout. Like I said, if we're in heating mode, as you can see here, our soft lockouts change in time. Sorry, I said 5 minutes. I wasn't cooling. The first one is a 15-minute, then a 30-minute, 45-minute, and then it goes into an 18-hour soft lockout period for the 4th through the 8th. Once we hit that 9th time, it's in a hard lockout. This is just to show you, but that 9th trip, this has been going on for a long time because each of the 4th, 5th, 6th, 7th, and 8th, that's 5 times, have been an 18-hour lockout. So this has been going on for a week or more, just FYI. So each soft lockout gets a little bit longer. If you're in cooling, we do the same thing. So not a big confusing part there. Only we don't go into a hard lockout on cooling, only in heating. When you want to test these coil temp sensor and the ambient temp sensor, in the service packs, it does have the readings for them, what you're looking for. Includes both the ohm resistance and the volts. We're looking for volts DC going to it for each of those sensors. It's easy to read. You'll notice here that these ohm readings are kind of high. So we're at like at 75 degrees, we're 10,000 ohms. So make sure your meter is set to do kilo ohms, 1,000 ohms. And make sure that when you're reading it, you'll look for a little K symbol usually in the corner of your meter. And just so you might say 10, like, oh, only 10 ohms. That's really hot out. No, it's 10K usually. So when you're trying to test these sensors, if you want to make sure, get some, make sure they're reading accurately. One of the most common things people do, we ask people to do to make sure that they're very accurate, is you put your sensor, you'll disconnect it from where it is, and you'll submerge it in a cup of ice water. Who carries ice water with them? Not many people. Most homeowners are willing to lend you some water and some ice if they have it, and you can test those sensors in 32-degree water. As long as your water has ice and water in it and it's stirred, you're going to have 32-degree water. So if you know it's at 32 degrees, you can get a pretty good idea of what your ohm reading should be. If it's a coil temp sensor attached to the coil, you have to get your temperature probe right there where it is at the same place, get the same temperature reading. Not always the most accurate. Especially if you're using a clamp style, you can't always get your clamps into the coil very well. And if you're using a clamp style, it's harder to get the ambient temp sensor. But if you have it submerged in a cup of water, the sensors are all waterproof. They should not have a problem. If they don't have a problem in the air, but they do in the water, that's also a sign of a bad sensor. Sometimes they get a crack in them, damage due to UV, ultraviolet, it's the sunlight hitting it for too long, for 10, 15 years, and they can crack and get damaged. Sometimes they get animals or critters chewing on them and they get cracks and damage. So it's important to kind of give them have people say they only have a problem when it rains. Well, only when it gets wet. All right, moving on from that defrost board, because that's it. Those are all the airs. If you look at those airs, they're almost all exclusively low pressure. So low pressure in those two sensors. High pressure cutout is wired in a way where it's not going to give us an air code. On our 2-stage, or even some of this, we've had a single stage unit with EEV. So if our heat pumps that are using an EEV in the outdoor unit, some of our 16, 17, or 18 SEER heat pumps, some of those have an EEV in them. They're going to have an EEV control board. This EEV control board looks a little bit different than your defrost control board, and it's got different plugs in different places, but it still has 2 lights on it over here, a green and a red. It's got its own set of air codes, completely different. So I want to make sure that when you look at your defrost board versus your EEV board, you're looking at the correct set of air codes. And a lot of people get them mixed up. They'll get a defrost board and look at the EEV airs, or get a EEV error and to look at the defrost control board errors. So make sure you're looking at the right board for the right error codes. They are two sets of error codes for two sets of boards, for two different boards. One big thing, we're going to look at some of the testing of this. I want you to see it does have a test point right here. That's for testing the pressure transducer we're going to get to. And here is our temperature sensor for the suction line that we're going to look at that as well. So those are the only two sensors on this thing. We have a pressure transducer and a temperature sensor on the suction line. The other parts here control the EEV stepper motor. These are the controls that go over back to the defrost control board. So you got a plug for the stepper motor, a plug for the defrost board, a plug for the coil sensor, or sorry, the suction temp sensor, a plug for the pressure transducer, and then a couple lights and some test pins. So looking at our EEV tests, or EEV faults, we have a list of 10. One of the interesting things that people run across, and I've run across this and didn't know at first what was going on. You'll notice that error codes 6 through 10, there's like a little divider here. There's a reason. They do not clear when you fix the problem. You have to manually clear these errors. Error codes 1 through 5 will clear on their own as soon as you fix the problem. But error codes 6 through 10, well, really 6 through 9 because 10 is not really used, but 6 through 10 do not clear on their own. So if you're getting a 6, 7, 8, 9 flash error code, dig deeper, find the problem. We'll go over what those could be. But that is going to be one of those things where once you do fix it, once you feel like you have it fixed, you have to manually go in and clear it. And it talks about it right down here. It says faults 6 through 9. This is right out of the service packs. Will be stored in the non-volatile memory. See the closed valve test for fault clearing procedures. Faults 1 through 5 will clear on a power cycle. So that's not a power cycle of the outdoor unit. That's a low voltage power cycle. So if you kill the power to the outdoor unit at the disconnect, it still has 24 volts coming from the indoor unit to power up that board. Those lights are still on and it does not clear the error codes. So when you want to clear these error codes, you're going to need to disconnect power, red, common, whatever you need to, kill the power to the indoor, which will then kill the power to this board. Faults 1 through 5 are really straightforward. They give us a very direct idea of what could be going on. So let's look at these real quick. A 1 flash, the coil has an open circuit or an intermittent short. So the coil we're talking about here is right here, the coil to the EEV. Okay. So that it's saying that the EEV stepper motor coil has a short. Okay. That's easy to test. We can unplug it, test it. I'll show you how to test that. Flash to 2 flash on this board. It says it's got an internal failure. Really no testing to do there. If it's giving you a 2 flash, there's something wrong with that board. A 3 flash, the pressure transducer input is out of range. Great. We can measure that. We can test it. It's got a test point right here next to the plug where it says plus VP. I'll show you how to test that, where the scale is for that. A 4 flash, also suction temperature sensor input is out of range. So that's this guy right here. So we're getting a bad reading on the suction temperature sensor. And the last one, coil has a short circuit. Now, the difference between this one and this one is between a 1 flash and a 5 flash. The 5 flash is going to cause it to shut down power to itself. It won't even try anymore because it's going to short itself out and doesn't want to blow the fuse. This one is saying the circuit's open, so it's an open circuit. This one's saying it's a short circuit, so a direct short to ground pretty much. And so it shuts off its own power. They are slightly different. Still probably going to be the same fix, which is replace the stepper motor, but it's really easy to test. The next ones, these ones will get a little more complicated. A lot of these ones may not be a problem with the actual heat pump, but let's look at these. 6 flash. The valve is not responding to a position change command. In other words, it thinks the stepper motor is good. It's sending power to it. It's trying to drive it. The suction temperature sensor is reading correctly, but it feels like when it gives a command, that valve's not moving. So that is telling us that we might have a stuck EEV. going through testing the EEV. If you know how to do that, great. If you don't, you can always call tech services and we can work with someone who's trying to, depending on what their symptoms are. A 7 flash, the valve is responding, but the system is not performing properly. So it feels like the valve does move. We are getting a temperature and pressure changes on the pressure transducer, but it can't maintain the superheat it's targeting to get, which means we might have a system that's low on charge. We may have a restriction in the system causing it to run erratically, but it's just telling us, hey, let's check our charge, make sure we're charged right. Kind of simple. 8 flash, compressor is not pumping. So this is kind of a funny one, though. Could just be a bad compressor, 100%. Absolutely, could just be a compressor that's bad. It also can be, and I've seen this happen, where someone has a blown fuse in the disconnect. So we don't have high voltage, but the defrost board does not know that. The EEV board does not know that. And so they're trying to run the system, but it's not running. Actually, just seeing a blown fuse give us an 8 flash. So the problem with this is, and this is where I see it most, is where the technician goes out, diagnoses we have a blown fuse in the disconnect, replaces the fuse in the disconnect, turns it on, and he's got an 8 flash. Compressor's pumping, system's running. Why do we have an 8 flash? Because over here, airs 6 through 10 do not clear after you fix the problem. They do not clear after a power cycle. They only clear after you manually clear them. So if you are getting any of these 6, 7, 8, 9, check your operation, go through it. If everything's running great, manually clear them and see if they come back. Because it may have been a problem that was maybe the homeowner took the power off. Maybe the painters came through and killed the disconnect while they were painting so they could wrap it. And when they turn it back on, system tried to run, but it sees this compressor not pumping because it was trying to run while they were painting and had it all wrapped up. Those kind of things can happen. So some of these problems are not really a problem. 9 flash, low superheated cooling mode. So it's reading some temperatures off the temperature sensor saying, hey, it thinks the indoor unit's got a problem. So at that point, we've got to go check the indoor. We got to check, make sure we've got clean filter. We got a fan that's running the right fan speed, all that kind of stuff. So it's telling you to check the indoor unit on a 9 flash. That could be something where you had a bad EEV on your TAM9 on an indoor unit, and they got that fixed, and now the outdoor unit's got an error code. Well, you fixed the problem. We still have to manually clear that. So real quick, before I show you how to clear it, here's in the service backs. You'll notice here we got 75 degrees, 10K ohms, the exact same scale as the other sensors. So this is for your suction line temp sensor, right back here on J10. And then you're going to have your suction pressure transducer. We're just going to measure volts DC. So as you can see here, volts DC at plug J7. Test point to common, okay? So we're looking between 0.8 volts DC to 2.5, not a lot. Here's your test point, and you're going to measure to common. Common, the blue wire coming into the outdoor unit, right? So from here to common, that little solder joint right there, while this is plugged in, it does not need to be running. It does need to be on. This needs to be on. And you should have these voltages will correspond to a pressure that should match what your suction pressure is on your system. So hook up your gauges. What's your suction pressure at the true suction, right below the reversing valve on the middle line? That pressure should match this pressure. If they don't, that means our pressure transducer is reading out of range. And we could get one of these errors right here, right? A 3 flash or a 4 flash. So real simple, to measure your pressure transducer, you just go, sorry, I'm bouncing back and forth really fast here, but you just measure right here on the plug, right next to it, there's a test point right there, little solder joint. People miss it a lot. You don't need to unplug this plug. You don't need to stick your meter into the back of the plug. You just need to test to that little solder point right there to common, aka to ground. And you're going to get somewhere between 0.8 and 2.5 volts DC. Okay. On the expansion valve, on the EEV itself, there's that little stepper motor. This is the coil here. You unplug that thing. We do not test it while it's plugged in. You'll unplug it from the board, and you're going to ohm, and it's got a little chart here. You have two commons, the brown and the red are common. The brown's going to go to blue and yellow, so yellow, blue. The red's going to go to orange and white, so orange and white. It's got two sets of commons, so you got two circuits there. You're going to measure all four of those. They should all come out the same. This should be right around 46 ohms. And now we're going to look at how do we clear these error codes. So if we do have those error codes 6 through 10, really 6 through 9 because 10 doesn't happen. It's in the notes. It's kind of buried. It is difficult to know where it's at. So I'm just going to read it to you real quick, and it's really easy to do. So we're going to do a closed valve test, which you're gonna short or jump between close and test. I'll go back real quick, show you where that's at. Right here on the EEV board, right next to the lights, you got close, open, and test. So you're going to put a little jumper or maybe a screwdriver, whatever you have there, between test and close. You're going to jumper between test and close right there. When you do that, you're going to clear the faults in the stored memory, apply a jumper between test and close for 10 seconds. So you're going to hold it on there for 10 seconds. After 10 seconds, you can remove your jumper and the errors should clear themselves, will be cleared. That being said, I don't like people who count to 10. 1, 2, 3, 4, because a lot of times people count too fast. I've had multiple people who did it and they only held it on there for 9 seconds or 8 seconds because they counted too fast. And if you do that, it doesn't clear anything. It just does a closed valve test. That's all it does for you. So make sure when you put it on there, everyone's got a smartphone nowadays. Take your smartphone out, start a stopwatch on it, whatever you got to do to make sure you get on there for 10 seconds, a full 10 seconds, and it will clear those errors. It's not difficult to do. It literally takes 10 seconds and you can clear these fault codes. Really simple. Test to close for 10 seconds. It'll wipe the memory of these faults and they'll go away. Now, if they're still having the same symptom after it's run, they could come back. So, depending on what the error code is, if it's an 8 flash, they had a bad fuse, great. You know what it was. You fixed it. That should not come back. But it's really simple. The variable speed units, our heat pumps out there. I'm not going to go, there are literally hundreds of error codes, well, over 100. I would say use the technical service manual if you have it, the red book. It is very helpful. Although all of our stats, and this is really important to understand, make sure everyone knows where to look. I get a lot of people who call in and they're trying to read the error codes off the little CDA at the outdoor unit. Look, it'll give you an error. It doesn't really give you too much detail. If you go to the thermostat and you go into technician access and go to the active alerts, it's going to give you the error code number. It's going to give you the name of it, tell you what the problem is, and it's going to tell you the likely causes, what could cause this error code to happen. Sometimes there's multiple reasons that could happen, 3 or 4 or 5 things. The thermostat will tell you all those things, whether you're using a 1050 or an 850 thermostat, or if you're on even the newer stuff and you've got the new Link thermostat, they're all going to have those error codes in the thermostat. They're going to give you the causes of them. They're going to give you where to look. These are really helpful. These thermostats, they kind of do your work for you sometimes. On the variable speed products, I would recommend whenever you're getting an error code at the outdoor unit, you go look at the errors codes on the thermostat, because that's going to give you the details. Now, if you just go to the thermostat where it has the error code flashing across the top and you just press and hold there to look at it, you're going to see the homeowner facing error code. It doesn't give you the details. It doesn't give you everything. You really need to get into the technician access and go to the active alerts. And that's going to, or even alert history, but the active alerts are going to tell you what's actually going on. And you can touch each error code and it'll show you exactly what is the likely causes. And they're pretty accurate. Are they 100% accurate? Not always. Sometimes you have multiple errors and you kind of have to piece them all together and to see which one is making the most, what makes sense when you have 2 or 3 errors. What could it be? You look at those 3 errors, put them together. But that's when it comes to the variable speed, there's not going to be a very simple flash code at all. So you're going to need to go to the thermostat and look it up. And there could be like 100 different errors. So I'm not going to try and go through every single one of those errors and waste too much of everyone's time. That's really it for this one, guys. We've gone through everything. If you have questions, go ahead and throw them into chat and we can look at what could be going on. If you have any questions, you want to follow up. And if not, if you want to go about your day, it's 7:30, a little after. Go ahead and have a great day. But if you have questions, I'll stick around here and answer any questions you got.